Hello and welcome to the ADS tutorial series of videos. In this video, we will talk about how to compare large port count data with great ease. As we understand, in a typical signal integrity or power integrity domain, often at times we end up with having a large port count and managing data for large port count comparing it against either the measured reference or even the different versions of our design could be quite challenging. So in this tutorial video, I will show you a technique how you could use ADS data display features to get around and achieve this objective very easily. So here, let me show you the end result of what we would be end up getting after we do some simple stuff in ADS data display. So here I have two sliders, and if I move these sliders, you can notice the plots on the graph will change automatically, and then we can see comparison of two datas which we have in this case, but in reality you could have as many data as you want to be compared. Now this data could be very easily managed depending upon what you want to compare in terms of magnitude of phase, or even running some custom equations to post process the data to derive the measurement which you might need for your application. So, well, this looks interesting. So let's see what we are talking about and what problem we have. So if you look at one of the sample, deck which I have two data sets. If I open these data sets, they are 16 by 16, and I plotted some of these as parameter. Now, if we have to compare these data plots coming from two data sets, which one of them could be either a measured data, or as I said before, it could be both of them could be simulation data coming out with different versions of our design and so on. So comparing and doing this kind of data comparison between different data sets or different files could be quite challenging because a user will have to double click on each plot, select the respective data set, and then figure out which data he wants to plot. And this is how traditionally he would start comparing the data. Now, doing these many clicks every time could be quite challenging and time consuming. However, if we build a simple template like this, our job is very easy. And by just manipulating these sliders, we could go ahead and compare the data. Right, sounds exciting. So let's see how do we go ahead and build a template like this for ourselves. So I will go ahead and create a new data display so that I show you how to build it from scratch. Now in this workspace, I have two data sets with me. I have test1 and test2, which are both 16 port S parameter data. And we can compare each one of them for whatever measurements we want to do. So the first thing we would like to do is create an array, which we will use as sliders to scroll through the various S parameter terms. Now to do that, we can simply write an equation of creating an array. So usually in theory, we refer S matrix as SMN term. So I'm going to create two sliders, one with M. And if we know the total size of the data, we could just simply type in the array something like this. So we have M from 1 to 16, changing in a step of 1. That's the simple syntax of this equation. Similarly, we'll create another array of data, which is again going to go from 1 to 16 in a step of 1. By having these two arrays, we have now 16 by 16. We could create an array for 16 by 16 matrix, as we will see how. Now, in order to move our data or scroll our data nicely, we would insert a slider. This is a very nice feature in ADS data display, where we could put a slider and assign a variable to it. So in our case, we will insert a slider, go to the equations data set. Equation refers to anything which we do on data display, and these are not part of our simulation data set. So we will have one uh, array or one slider defined for M, and similarly we can also just resize it a little bit, and we will insert another slider, and this time we would select N to be part of this slider. So I'll go ahead and put N onto that, and again we will go ahead and resize it. And now if we don't want to see this text, we can switch off these texts from going to options. But for now, I will just retain as it is. So we have two sliders, and we do have two markers, one on each slider referred to as M1 and M2. Now we will go ahead and write a very simple equation to attach these sliders to extract the S parameter data from our entire S matrix. Now, if we notice, the S matrix size is already known to us in this case, which is 16. But in case you are not aware of the S matrix size, later I will show you how to write a simple function to calculate the size of data. And then you can make this array or the sliders to be totally dynamic, and it becomes kind of universal, and it will work with any dimension of data which you may have, not only restricted to 16 by 16 as in this case. But let's go ahead and make this work first. So once we have these basic things in place, we'll go ahead and write a simple equation. And I would call my first data as data 1. And data 1 will come from my first data set. And right now, my first data set name is test1, and the another one is test2. So we will name the data set and then dot dot, which represents the data which we want to extract from the S matrix. Now, using S matrix, I could either hard code the number. For example, I could type something like this, and if I click apply and OK, you can see this equation is valid. And by this manner, I'm able to get the data from test1 data set. Now let's copy paste this equation here, and I will call it data 2. And data 2, I just need to rename this test1 to test2. If you recall, these are the two data sets I have in this particular workspace. So this is right now a static method of bringing or reading S11 from test1 dataset to data 1, and S11 from test2 dataset into data 2. And if we insert a graph, and again going to the equations dataset, I can see data 1 and data 2 is here. So I'll just go ahead and add them onto my graph. So right now with this step, I have S11 data from both of these. And as you can see, the red data belongs to test 1 and the blue data belongs to test 2. Right. Now, how do I make it dynamic? Because if I want to compare S21, S47, S27, S29, or whatever term, we can make this whole thing changing dynamically when we move this slider. The simple way to do that is, instead of hard coding the number, we could refer them as M1 and M2, which essentially will read the values of M1 and M2 here. Okay. And similarly here, I can change it to M1 and M2. So once we do that, now our plots, the data read into data 1 and data 2 will become dynamic, and it will be dependent on these marker positions. Now, if I go ahead and change this marker location, you notice both of them change. And then we can see both of these plots getting updated for the respective S parameter term. But sometime when we do that, we are not sure which data are we looking at, because it's kind of difficult to estimate. For example, if I move my marker location here, sometime what we are not clear what data it is coming. So we can even add a readout here which indicates what data is being shown on the plot. For doing that, we can simply use this text option and we will write a text. So we can say something like now showing S and put bracket. And now in order to read marker information or the marker position information into a text, we simply use this at keyword and we say at M1 at M2. And once we do this, you can notice it clearly shows what data we are reading. And once we move the marker position, this readout also will keep changing. And this way we are 100% sure and we have information on our fingertips what we are reading and for what S parameter term we are plotting. So this is pretty scalable. I could go ahead and save it as a template and I can just insert this template whenever I perform a new simulation. The only thing I need to take care while inserting this template, I just need to change this dataset name to the appropriate name as you might be using in that particular workspace. Now, one thing which I referred earlier is if we know the data size of my S matrix, I could very simply create this static kind of array. But in case I'm not sure and I want to make it even more dynamic, then I could write another equation. Let me show you how can I find the size of the data, and then I can make my arrays scalable. So I'll go ahead and put a new equation and let's call it data size. In ADS, there's a function called size, and that size function, if we pass an argument inside, it will give us the matrix size or the array size of the data. For example, if I call it test1 dot dot capital S, so this will tell us the S matrix. If I press OK, you can see the equation is black and it's valid right now. And I will go ahead and use this table plot and I will go ahead and insert a table here. Go to equations and add data size into this table. So here you can see it is telling me I have 16 cross 16 S matrix as in test one. Similarly, if I just control C and control V, that means I copy and paste and change this to test two. And now I plot data size one as well here. It also shows me what's the data set. Now, currently both of these S matrix are 16 cross 16. And that's why this whole template is working very nicely. And logically thinking, if you want to compare all the S parameters on both matrix have to be same size. So there is no surprise here. So now once we have this variable being calculated dynamically with the data set, instead of typing 16 as a hard code number here, I could just simply say data size small bracket 1, and that will make this equation to be completely dynamic. And similarly here, I could type data size 2. Data size 1 and 2 are the two components of this data, which gives us M and N to construct a SMN matrix, right? Now with this, if I go sample data creator for 16 cross 16, and I'll go ahead and let's say disable these two terms so that now it will become 12 port matrix instead of 14 port matrix instead of 16 port. Let's say disable term 15 and 16. Right, so we'll just simply create a new data set. And if I go back to my original data, now you can notice it is 14 cross 14 S matrix, and the other one is 16 cross 16, right? Now, because both of our arrays are defined in terms of test one, which in array notation means 14. So here, the whole thing can change dynamically. right? Now let's go back to our schematic and enable these two again. And we go ahead and run the simulation to create a new data set of 16 ports. And if we come back to our original thing, now we are back to the condition where we have 16, 16. So you can do a lot of these creative things when you use ADS data display. There are tons of features. I welcome you to explore more features about ADS data display, and I'm sure you will find it very, very powerful to create your own data processing the way you want. And not to forget, ADS data display now has a direct link to Python, and Python is totally integrated. So if you want to do more complex data processing, feel free to use data link options in ADS and do the data processing using Python and display either using Python 3D plots or native plots of Python or using data display from the post-process results coming out of Python. So best of luck for your design and hope you like this video. Thanks very much for your attention.